Hi everyone, we are continuing today with section 6.1 and we're now going to start talking about ordering fractions. This discussion starts on page 203 of the textbook. So one thing that is going to be common with all of the numbers that we are going to work with in this class is this concept of order. And this concept of order really is there because of the number line. Because all of the numbers that we've looked at so far and that we will look at, so more specifically, the whole numbers, the natural numbers, the integers, and now fractions, which include rational numbers, and then eventually real numbers, all of these can be represented on a number line. And so because we have this number line that we can use to represent all of these values, we can order them. So just kind of drawing out what's in the book is that we have this concept of order. So if we have a number line, it goes 0, 1, 2, 3, 4, and we look at two fractions, and one of them is here, and this is the fraction a over b, and one of them is here, and this is the fraction c over d. That depending on where these fractions are on the number line, we can put an inequality between them and say that a over b is less than c over d because it's closer to 0 on the number line. So that's why we have this concept of order for a lot of different fractions. Okay, so we want to kind of look at if we have two fractions and they have the same denominator, right? So we're actually in the case where we're not in c over d, we're in c over b. Which fraction will be the smaller fraction if they have the same denominator and different numerators? So this may be kind of confusing for students and maybe even confusing for you at first to think about, well, what do these things really tell me? This is a really good question to test if your students understand the concepts of the part to whole about a fraction. So we're going to kind of think of this remembering our part over whole relationship. So recall we've said that fractions don't always represent part to whole. Sometimes they represent part to part, but that's not until section 6.4 when we start talking about that. So for now, we're still talking about part to whole. Okay, so since the denominators are the same, what does that tell us? So since our denominators are the same, our whole has the same number of parts. So if you're thinking about this kind of using one of the models, right? If we have like a circle and our denominator is 4, we would break up the circle into 4 parts. So this is telling us that these two fractions that we're looking at, the whole has the same number of parts, but they have different denominators. So they have different numerators. So one of the numerators will be bigger. So one of the numerators will be bigger. So that fraction has more parts, has more, I guess pieces is better to say, has more pieces. So if the denominators are the same, we can think about we're comparing two circles, right, that both are divided into something like 4 quadrants. And we have a different number of quadrants in the two different fractions because one has a numerator that's bigger, that has more of those, and one has a denominator that's smaller, that has less of those different pieces. And so the numerator that's bigger has more pieces and is larger. So in this case, the fraction with the larger numerator will be the larger fraction, and likewise, the fraction with the smaller numerator will be smaller. Okay, so question 2 says if the fractions have the same numerator and different denominators, which fraction will be smaller? Okay, so this one, they don't have the same, if they have different denominators, then their whole has different number of parts. Okay, so I think an easy way to, a way to kind of visualize what's going on here is to draw a picture. So we have a circle that's divided up into 4 quadrants. And we have another circle, kind of a bad circle. We have another circle that is divided up into 5 quadrants. And say that we have 2 of each of these quadrants. So we have 2 quadrants here. 2 of each of these, I guess, pieces of this, parts of this whole. So we have 2 here, 2 of the quadrants, and then 2 of the fifths down here. Okay. Okay, so we want to compare them. So when we look at a model like this, it's clear that, or it should be clear, if you draw them nicely, that this top one represents more, right? This top one, these 2 parts out of the 4 represent half of the entire figure, whereas these 2 parts out of the 5 parts in the bottom figure don't represent half. You can see that, right, half is kind of represented right there, but we don't have that. We don't have that. We have less than half. So let's kind of think about how to say this in words. So we have this picture that shows us what's going on. But we can also say that if the numerators are the same, then we have the same number of parts, but we have the same number of pieces of different sized parts. So since the numerators are the same, we have the same number of pieces. Since the denominators are different, so since the denominators are different, we have different sized parts. So the fraction with the larger denominator right here, the second figure on the bottom, has smaller parts, right? Because our whole is broken up into more pieces. And so our whole is broken up into smaller parts, right? 1/5 is smaller than 1/4. So the fraction with the larger denominator has smaller parts and is smaller overall. Right, because these each have the same number of pieces. They each have 2 pieces, but if we have a smaller denominator, our whole is broken up into more parts that are smaller. So we have smaller parts and we have the same size. We have 2 pieces of parts that are smaller. So that means that it's smaller overall. Okay. So now the next question is again kind of hard. But I mean, all the questions on this page are really conceptual, and it's much easier to think about questions where we just order fractions and tell you which one is smaller or larger. But these are kind of general rules that will always hold. So now this next one talks about, let's think about if we have a fraction of natural numbers, right? Where A and B are 1, 2, 3, 4, 5, 6. One of the numbers 1, 2, 3, 4, 5, 6, 7, 8, and so on. We want to create a new fraction that adds 1 to both the numerator and the denominator. So in this case, we're changing the numerator and the denominator. Okay. So let's kind of have a motivating example. So sometimes if you're asked to do something generally, and it's really hard, it's easier to just kind of look at an example. So let's look at 2/3. And when we add 1 to both of them, the numerator and the denominator, we get 3/4. So okay, 2/3 is, let's try and make this problem something that we just talked about. So 2/3 and 3/4 have different numerators and denominators, but let's kind of try and see how we can make this, transform this problem where we look at these two fractions to looking at fractions that have the same numerator or the same denominator. So one way we can do that is by noticing that 2/3 is 1/3 away from 1, and 3/4 is 1/4 away from 1. Okay, 2/3 is 1/3 away from 1, and 3/4 is 1/4 away from 1. And now we have two fractions that have the same numerator but different denominators. So using what we just did above, the fraction with the larger denominator is smaller. So we know that 1/3 is bigger than 1/4. Okay, so since 1/3 is bigger than 1/4, 3/4 is closer to 1 on the number line. Okay, so because we know that 2/3 has to be further away from 1 because 1/3 is bigger, so that means that 3/4 is closer to 1 and is bigger. And it is the bigger fraction. Okay, that would mean 2/3 is smaller. Okay, so this is an example, right? This doesn't prove this generally. It doesn't prove it generally, but it can kind of indicate to us what should happen. So what should happen is that if you can do more examples of this to try and kind of convince yourself that this is what should happen. But what should happen is that in all cases, so in general, we can see that a plus 1 over b plus 1 is always closer to 1. So a over b is always smaller. So I don't expect you to be able to show that this works in general. It's just kind of one thing to think about, but this is one way to that if you're trying to compare fractions with a different numerator and a different denominator, that one kind of method to solve this kind of problem is to change what you're looking at and change it from looking at fractions with different numerators and different denominators to instead looking at fractions that have the same numerator, either the same numerator or the same denominator, like 1/3 and 1/4 here. And in general, yes, this is the case, but again, I don't expect you to be able to show this. I just have this problem on here to kind of show you how to change problems to fit what we do know is true in general. Okay, so the last video will be about benchmarks, and that'll be for next time.